In this set of notes, we're going to talk about geometric mean, and what the geometric mean is using similar triangles in a right triangle, that if you have a certain ratio set up within those sides, that we can solve for missing pieces. So geometric mean is the positive square root of the product of two positive numbers. So if you see, this is what it is. So x is the geometric mean of a and b. So sometimes you might see this sentence written out, and that tells you that the x part of it, whatever is the geometric mean, that's the part that's going to be doubled in your proportion. So let's go ahead and start setting up and solving. Number one, the geometric mean of 9 and 20 is what we need to find. So the 9 and 20 are like the a and the b values, and then we need to solve for the x. So we can cross multiply to solve it. So we get x squared equals, and 9 times 20 is 180. To undo the squared, we need to take the square root of 180. So when we do that, we need to write it in simple radical form or exact form. So let's go split up with our factor tree. I know that 36 times 5 gives me 180, and then 36 gives me 6 and 6, and there's a pair. So I can set up that this is 6, and then the square root of 5 would be my answer. So now for number 2, let's set that one up together. So notice this one says the number x is the geometric mean of 5 and 12. So that tells us that x is the part that's doubled, and then our 5 and our 12 are the other corners in our proportion. So now I want you to go through and I want you to solve this for x. When you multiply, you should have gotten x squared equals 60. When you take the square root of both sides, we get x equals. We got to do our factor tree, so you should have done 6 and 10. You could do 2 and 3, and then 2 and 5. So there's a pair of 2, so that goes outside. The 3 and the 5 are left over for the inside, so you'd have 2 square root 15. So those two questions were more just how to solve it once it's set up, or just to set up your ratio. But now if we have a right triangle, there's some things you want to know. If we have the altitude drawn for that right triangle, and connecting to the hypotenuse, it forms two similar triangles. And it's also similar to the original triangle. So there's different sides that we can pair up together. So one of the things that we can do is that this altitude of our triangle is the geometric mean of the lengths of the hypotenuse. So the different pieces of your hypotenuse. So that would be my x, and that would be my y. So if you look at our situation right here, if I set this up, my y and my x are the two different pieces. My h is the geometric mean of those two. So that's going to be the setup of that proportion. So there's another way we could do it using the side lengths. And it starts out that the length of the leg of the right triangle, so if we do that for letter A right here, that the leg is the geometric mean of the lengths of the hypotenuse. So that would be my C. Or it's also geometric mean to the segment of the hypotenuse that's adjacent to that leg. So the adjacent leg would just be the x portion of it. So if you look at my proportion right here, I have that my A, that's the geometric mean, is the geometric mean of the adjacent leg and the hypotenuse. So notice I switched the x and c, but that's okay because it's still going to multiply together. So if we look at it the same way for the other side, this would mean that our leg, so my b value right here, is the geometric mean of the side closest to it and the whole hypotenuse. We can use these now to find our missing pieces in this next triangle. So if I want to find my x is the altitude. So my altitude is the geometric mean of the two pieces of the hypotenuse. So that would be of my 10 and my 2. So that's how my proportion would be to set up. So let's go ahead and solve that for my x. So we would get x squared equals 20. We need to take the square root of both of those to solve it. And let's break this down. We've got 2 and 10, and then 2 and 5. So we've got a pair of 2's. So we'd have 2 square root 5 for our x. Now, if we're moving on to the z portion, I'm going to switch up my colors. So if I'm going to do the z, my z, because that's the leg, is the geometric mean of the whole hypotenuse, so that would be 12, and this side, the leg that is closest to it, so that would be my 2. So if we solve this, we get z squared equals 24. To undo the squared, I take the square root of both sides, so I get z equals, and let's see, we can pull out a 6 and a 4, that would be a 3 and a 2, and then a 2 and a 2, so a pair of 2's. My 3 and 2 go back together, so I get 2 square root 6 for my z. So now I want you to set up what you are going to do then to solve for y. What you should have set up for your y is that y is the geometric mean of 2 pieces. So it's the geometric mean of the closest leg and the whole hypotenuse, which would be 12 again. So then you should have solved and gotten y squared equals 120. When you take the square root of both of those sides, we get y equals, and we did this up above at the very top before. Oh, no, I'm wrong. We could do, let's see, 40 and 3. That would be 4 and 10. I'd have 2 and 5, and then a pair of 2's. So I'd end up with a 2, and let's see, we've got a 3, a 5, and a 2 to put back together. And that becomes a 30. So 2 square root 30 would be your answer for letter Y. So going on to number 4, we're going to set up the same way. So let's start with our z over here, and it doesn't matter which side you start with. So I know that my z is the geometric mean of the side that is the edge that's closest to it, and the whole hypotenuse, so that would be 25 plus x. Now if you notice, we've got a problem here because we have z's and we have x's in that problem, so we have to hold off on that, and let's go to one of the other ones and set up those as well to see if we can solve one of those instead. So let's look at the y. So my altitude is the geometric mean of the 2 pieces of the hypotenuse, so that would be 25, and that would be my x. And again, we've got a problem because we have y's and we have x's in this, so we got to move on. So the next thing we can do is the other leg. The other leg then, if we've got that one, is the geometric mean, so that's the part that's doubled, of the side that is closest to that, and that would be the 25, and then the whole hypotenuse, so that would be 25 plus x. Now if you notice on this one, we can solve it for x because there's only x in this proportion, so this is the one we're going to start with. So let's go ahead and cross multiply, so 65 times 65, and then we have 25 times 25 plus x, and we need to distribute that. To solve for x then, we need to subtract the 625 to the other side, and we get 3,600. Then we can divide both sides by 25, and we get x equals 144. Now remember, some of these other ones had x's in them, so we need to put those into those problems so that we can solve them. So over here, this would be really a 144. 144 plus 25 gives me 169 instead. So now we can go back over here to the z's, and we can cross multiply for those. So we'd have z squared equals, and then we have to take 144 times 169, and we get 24,336. To undo our squared, remember we have to take the square root of those, and that is a perfect square, and it comes out exactly at 156. So lastly, I want you to take this last one, and I want you now to solve for y. What you should have done is gotten y squared equals, and then 25 times 144 is 3,600. To undo that, we have to take the square root, and that gives us our y comes out exactly at 60 for our final answer. So remember, when you are setting up these ratios, always remember, come back to these right here. So your height, or the altitude, is the geometric mean of the 2 pieces of your hypotenuse. And then your leg is the geometric mean of the closest edge and the whole hypotenuse. So just remember those general words right there, and that'll help you set up any of your different ratios.